Hi everyone, thank you for watching my YouTube contents. I'm Sam Kim. In the previous video, I showed you how to do proportion test and chi-square test in XLNR. And in this video, I would like to talk about the application of proportion test and chi-square test. As you may know, A/B test is very popular in e-commerce website web advertisements analysis. Let's say there are two marketing campaigns. Type A is buy one get one free campaign, and type B is price off campaign. And when you do a A/B test, there's one thing I want to say in terms of proportion. As you can see, the first one and the second one shows same proportion, right? The only difference is sample size. So in yellow, in this situation, actually it's not significant under 5% significance level. However, the green output shows same proportion like yellow output. However, sample size is 10 times bigger than yellow output. So in this case, actually it shows significance. It shows statistically significant output because of different sample size. So when you do A/B test, I recommend you to check sample size to clearly understand the difference between two proportions. All right, and let's move on to decision tree. So in terms of decision tree, there are many algorithms we can apply, and one of the popular algorithm is trade algorithm. Trade is the abbreviation of chi-squared automatic interaction detector. Okay, and I asked to ChatGPT which algorithm is the best for categorical decision tree, and it says there isn't definitive best algorithm for creating categorical decision trees, right? But however, here are a few notable ones: trade, cart, classification and regression trees, and C4.5, ID3, and random forest. The second question, which library is the best for decision tree analysis in R, and it actually shows five libraries. And based on my experience and personally, I think R parts is very practical. However, for in this series of video, I'm talking about chi-square test. So I want to show you how to use trade libraries for decision tree analysis. So let me use iris data. However, I will convert all continuous data as categorical data. So all variables are categoricals. Okay, categorical variables for y and x, right? So let's generate a rank. And by using rank, we can generate categorical variable. Let's say more. We can think of four labels based on this range, rank range, and we can use the lookup function. Lookup vector here, result vector here. And let's copy and paste new spreadsheets. And let's copy species as y variable. Okay, and then let me delete some data. The main reason is actually I want to show you that decision tree can handle this missing data for analysis. Then let's save it as CSV format. And let's say iris, categorical, and missing. Right. Let's run RStudio. let's check our version, and let's read the data which I generated. Then let's use Shade library. So in order to install this Capital Shade library, you need to use this repository, right? And let's activate this Shade library. Okay. Then without doing any converting activity, let's try to use Shade function. Then actually, as you can see, there is an error. Is that factor x is not true. It means that x variables are not factor variables. So we can use lapply function to convert all variables as factor variables. Okay, then let's try to use Shade algorithm again, and I specify an action as na.pass to include all items, which includes missing data. Then let's draw plot here. Okay, if you specify type as simple, okay, then it shows like this. Then let's add all samples in each node. 46 plus 4 plus 35 plus 3 plus 26 plus 12 plus 24. Then again, as you can see, this sensory output actually includes all observations which has some missing data, right? So again, let's copy and paste in Excel. Okay, as you can see, all 1, 2, 3, 4 are categorical variables. So this is how to interpret this entry. So if petal width is 1, then it predicts species as Virginica. And if petal width is 2 and petal length is 1 or 4, then it predicts a species as Virginica. And if petal length is 2 or 3, then it predicts a species as versicolor, right? Right. This is how to read this entry. So this entry output is based on Shade algorithm, and Shade is the abbreviation of, as you can see, chi-squared automatic interaction detection. So in the near future, I will try to cover more about RPart and Shade algorithm. But in this video, I wanted to show you how to use chi-square tests in this entry analysis. I hope it was useful to understand how to use proportion test and chi-square test. Right? Please click like and subscribe if it was useful for you. Thank you.